Hi, my name is John Luchai, and my student Ross Kester and I are going to present some information on the water levels in the confined aquifer system of northeast Wisconsin, specifically in the groundwater management area near Green Bay and the Fox Cities. Unfortunately, Ross's work schedule didn't allow him to attend the conference, so I'm presenting on his behalf. The purpose of our study is pretty straightforward. It's a follow-up to a published study from 2017 that outlined a century of water level history and groundwater use in this groundwater management area. What we basically did was look at water well construction reports and other water level data available through the USGS, from water utilities directly, known artesian wells, and DNR abandonment logs. And we basically figured out what the surface elevation was, subtracted static water levels, and created water level elevations in wells that penetrate the confined sandstone aquifer. We contoured it in ArcGIS, and then we sort of traced those contours and cleaned it up using Adobe Illustrator to make it look pretty. If you're interested in more details about this sort of sustainability study, I'll direct you to this article that's over here on the right-hand side that Dave Hart and I wrote along with two students, Julie Moss and Jonathan Odekirk. The geology of the Northeast Groundwater Management Area consists of eastward dipping Paleozoic bedrock. There's an upper karst aquifer that's Silurian in age. It forms the Dora Peninsula and the eastern side of Wisconsin. I'm not going to talk much about that. What I'm going to talk about is what's beneath the two aquitards, the Sinope group and the Maquoketa Shale. And that's really a confined sandstone aquifer made up of Cambrian and Ordovician sandstone units. And across eastern Wisconsin, these are some of the most prolific aquifers. The red area outlines the Northeast Groundwater Management Area, which is defined as an area that has more than 150 feet of drawdown since pre-development conditions. And Green Bay and the Fox Cities near Appleton, Little Chute, Kaukauna, Kimberly, and places like that are where the major centers of pumping are for this groundwater management area. In this area, recharge is to the west at higher elevations where the sandstone units are near the surface. The blue arrows show the sort of progression of water as it recharges and enters the aquifer, and the rocks are dipping to the east. So in this particular area, originally the potentiometric surface was nearly 100 feet above ground level, leading to flowing artesian wells being common in the late 1800s to early 1900s. Now, flowing artesian wells are fairly rare. I want to make it clear that the water level history in the Great Lakes and the wet climate we've had in the last couple of years are not related to water levels in the deep confined aquifer. It's because of this confining unit made up of the Sinope group and the Maquoketa Shale that really limits the interaction between surface water systems and this groundwater system. So it's really the pumping history that affects water levels to the greatest degree. The water use history is something I don't have a lot of time to go through today in this 12-minute talk, but I'll direct you to that other paper that we published in Geosciences a few years ago. What's really important to know is that there are two major transitions from groundwater use to surface water use, one of which occurred in 1957 when Green Bay built a pipeline shown here in blue, and it switched, changing most of its water use to surface water. And then again, after a 50-year period of growth, 8 communities surrounding Green Bay, 2 of which shown in green hooked up with Green Bay, Scott and Ashwaubenon, and 6 other communities that formed the Central Brown County Water Authority made a pipeline. They made this red pipeline 65 miles long to Manitowoc. As a result, water levels during both of these transitions recovered dramatically, well over 100 to 150 feet, in some cases more, and what we're ending up with is some major changes on long-term hydrographs. The one I'm going to focus more on today is the work we did in response to this second transition. 2004 to 2005 saw the deepest cone of depression, and in 2006 and 2007, 8 communities turned off their wells. And this was followed by a couple of other communities, but ultimately 75 to 80% of the water use from the groundwater system ceased, and water levels rebounded pretty substantially. Here's just an example in the 2006 to 2014 time range, and you can see the cessation of pumping about 3/4 of the pumping was turned off in central Brown County, and it was mostly as a result of the municipal supplies changing to surface water. There aren't many long-term hydrographs in the area. The one that is the longest term is unfortunately just abandoned a year ago, but this blue line represents a deep aquifer well where we have water level data since 1950. And you can see the first transition as water levels were declining and Green Bay turned off its wells. Water levels recovered in just a few years. 50 years of growth caused water levels to decline again, about to the same level. It's just that the center of the cone moved farther away from this well, so it doesn't look as impressive on here, but the cone of depression was equally as intense. In 2006 and 2007, in response to radium regulations and long-term water quantity concerns, those 8 communities turned off their wells, and there was another substantial rise. But unlike what happened in 1957 through 1960, the water level rise has continued now for 15 years, and the recovery is continuing. The black line here represents the well that's closest to the center of the cone of depression where we have data, and that's at the National Railroad Museum in Green Bay. I also compiled some data from the Green Bay Water Utility, and this really shows the water levels in the area drawn down not by Green Bay, because their wells were off, but by the surrounding communities. And in 2007, that switch really caused water levels to rise dramatically. And that rise has continued until this day. And there are 3 wells that have shown either flowing characteristics or water levels right at ground surface within the last 3 years or so. The next couple of slides are really going to show you what happened from 1990 until 2020, so a 30-year period of water levels. The first group of maps are from the paper that we published in 2017, and the last map is our update that we're presenting on today. In 1990, Green Bay and the surrounding communities had a pretty intense cone of depression, and there was a smaller one here near the Fox Cities east of Appleton. So 2 distinct cones were evident. By 2000, the northern cone had become more intense and larger, and the same thing was happening in the southern cone here. So water levels lowered and the cone became more pronounced. By 2004 to 2005, this is when the cone became the most extreme. Water level elevations in some of the wells were below 80 meters above sea level. So Green Bay's water level is 177 meters for reference, or 580 feet above sea level. So that's a substantial drawdown, considering the original potentiometric surface was probably at about 210 meters above sea level. So lots and lots of drawdown. The cone of depression in the southern part also deepened and is now below 160 meters. The next slide is going to show you the dramatic change from 2005 to 2008. Remember, the switch by these 8 communities happened in 2006 and 2007. So really, just about a year after the switch, this is the difference. A much less intense cone of depression here, although it's still a substantial cone, and not a lot of change in the southern cone, maybe a slight eastward expansion. 2009 and 10, we're starting to see some lower water levels in the south and water level recovery slowly happening in the north. And by 2011 and 2012, not much is changing in the southern cone, but the water levels are just creeping up little by little in the northern cone. The biggest changes really started to appear in 2014 to 15. Water levels are still rising, but we're starting to see another cone developing northeast of Green Bay as people have built a lot of homes around the lakeshore here, and there's a lot of draw from Dykesville, the city up here, and lots of other building. So there's thousands of homes in this area that are drawing from the deep aquifer. The southern cone has gotten more substantial, both in its width and its intensity here, and so you can see these 2 cones are starting to swap which one is more intense. These were all images that were presented in the 2017 paper. The next one is going to be our map that we created for this talk. So here's the most recent data from the last 2 years, and you can see the northern cone has essentially dissipated. It's not really even recognizable as an obvious cone of depression. If anything, we pretty much see what's going on up here northeast of Green Bay. The southern cone, however, is pretty similar to what it was. A couple of water levels, like in Kaukauna, have risen slightly, but in other communities, they've continued to decline. So at best, the southern cone is stable, and at worst, it's slowly declining, probably slowly declining. At the end of the day, so the left panels are from the paper, the right panels are new data set. You can really see how striking the difference is between the early pre-switch and now in a 15-year period. Substantial differences from changing 16 million gallons of pumping per day in Central Brown County down to only about 4 million gallons per day. The last thing I'd like to talk about is why hasn't the cessation of pumping in the northern cone affected the southern cone very much? Regional planning commissions predicted that the water levels in the southern cone would rise in response to the rise in the northern cone area. You can really see there's been a lot of recovery here. So why would this not change the southern cone? It really looks like it has not affected the southern cone by rising its water levels. And I think the reason is this black line drawn here represents a very substantial regional fault with over 100 feet of vertical offset. This has compartmentalized the aquifer, and we can see it evident in water quality and isotopic differences sampled on either side of the fault. So I really think what we're looking at is a boundary, a sort of a boundary condition in the aquifer that's allowing east-west flow to occur, but not north-south exchange. And so at the end of the day, maybe these are two different groundwater management areas. Their proximity is close enough, but their behavior is substantially different. So in conclusion, the Northeast Groundwater Management Area has a geographically variable sustainability. The northern cone sees rising water levels, the aquifer has a sustainable condition, and there's actually additional capacity available for industry. Flowing artesian wells are actually a side effect, a problematic one in reality, that we see on the northwest side of the city and in areas along the bay shore to the north and west. There's a small cone developing northeast of Green Bay, and the southern cone is really where the action is going to be at. This is the place where we're uncertain what's going to happen. We see declining water levels overall, at best sort of stable water levels, and monitoring is necessary. So I encourage the USGS and State Geological Survey to invest in dedicated monitoring points in the southern part of this groundwater management area. And I think that's going to happen. Thank you very much, and I hope you enjoyed the talk.